2, 1. No? So, I'm not trying to teach you this. You got to understand. So what am I doing? I just want you to realize this kind of thing exists. It's called Pascal's triangle. What would the next line be?
1, 4, 6, 4.
Right? So if I had x plus 1 to the fourth, so it would start off the highest power. See how the powers go down? So it'll be x to the fourth plus 4x cubed. I like it. Good. 6x squared plus 4x plus 1. A beautiful shortcut. Can you imagine doing this by hand all the way? Right? X plus 1 4 times. So this is a huge part of mathematics, is math people going, I don't want to do x plus 1 to the fourth. Let's come up with some kind of shortcut, please. And this Pascal's triangle is used in a lot of different ways, not just this way. And again, you don't have to understand this. I'm not going to test you on this. This becomes big later in mathematics, but I just like to show people this kind of thing exists. It's kind of neat. It has to do with something called combinations too, about like probability stuff, but again, I'm not going to get deeper into that. Has anybody else ever heard of that Pascal's triangle?
Yeah.
Yeah, some of you guys? Okay.
I was robbed.
What's up?
I said I was robbed.
I'm sorry, buddy. All right. See where do I want to go? Oh, yeah. So, what about this here? This is a little tiny example of this thing we did earlier. 2x plus 3y times 2x minus 3y. Take a second and do that for several seconds. Oh, before I forget, I want to have a quiz on Tuesday. So that means we're going to have a quiz on Tuesday. Section 6.1 through... Yeah. Where am I? Yeah, all right, 6.1 through 6.3. I like it. Yes? Get that into the camera. People at home. Alright. So this is kind of like the Pulp Fiction problem, the one that had the small one, the big one, a lot of shit canceled. This is a much more direct. You can see why things happen, because you're going to get, alright, 4x squared, that's great. Then you're going to get 2x times negative 3y, and then 2x times positive 3y. So of course the middle terms are going to cancel, because they're the same thing, opposite signs. So you get you get minus 6xy plus 6xy. And at the end you get what? Minus 9y squared. So these guys die. 4x squared minus 9y squared. So math people being really creative, we call it the difference of squares. So every piece of that is a square. And it's being subtracted, so we said it's the difference of squares. That's what it's called. You guys all right with that? You guys see that? Is that something you should know ahead of time? No, because you just do the process and these naturally kill each other. So you didn't have to know it ahead of time, but it is kind of nice to realize when you got that happening, you can actually, if you get really good at this, you can just not even write this shit down. I'm telling you, don't do that because you're going to be wrong sometimes. You want to let it happen. You want to make sure it's actually going to happen. Okay, maybe. All right, what was the last thing I wanted to do? I forgot. Oh, just a little preview of something here, and then I'm going to let us out very early. Because I'm dragon, so you must be dragon. All right, I did all I said, yeah. Okay. I want to get a little preview of what's coming. Make sure I didn't do anything freaky there. No, okay. And get into, oh, beat it. Okay. All right, I know what I want to do. So, I don't know if anybody is curious about this. When we did all the power properties, we did what happens when you multiply like bases, divide like bases. We did what happens when you have a zero power. We did all that shit, right? What the hell would this mean? I love it. Some of you guys know. Do you know why that means that? So, I don't know if you remember, when we investigated this, what we did, or what I did, but what we did was I made a problem so that the properties would make it be 0, but there was another way to look at this. Something divided by itself was 1. So let's do something similar with this. If I had x cubed on the top, what has to be on the bottom so that the property would have a -1 here? Because when you divide, you subtract. So the bottom's got to be 1 bigger, right? Now, is there another way to look at, so we know this is true. Is there another way to look at this? Yes. There's 3 x's on top, 4 x's on the bottom. How many cancel?
3.
How many are left?
1.
Where? So you guys had said it becomes 1 over x. You're correct. And really, that's partially why. So think about it this way. If I multiply two things with positive exponents, right? I should be getting more of that thing. I had 2 x's multiplied by 3 more x's, so of course I'm going to get 5 x's. If I wanted to have 4 and I want to lose an x, I could divide it by x, right? Or, how else could I lose an x if I had x to the -1 power? Because then what happens when you add these? It becomes 1 less, right? But so you see how this must equal that in order for that to be true. In order for them to equal the same thing, a negative power actually means you're losing an x. And that kind of makes sense. Negative means I'm losing. So the negative power, meaning you flip it, makes sense. Because then you're losing that. Very hopeful. So what does this mean, Jeff? I don't know anymore. So this doesn't change any properties. It's just another thing I know what it means. So for example, we already did that, but what would this be? There's 2 kind of ways to look at this. What I always recommend is any negative powers, flip them. So not only does it mean x to the -1 becomes 1 over x. In general, it means wherever that negative power thing is, it wants to be on the other side. It means flip. So these would flip up, and it would become x cubed times x. So that flips up. It doesn't like it down there. I don't want to be in the basement, Mom. So then I move up. And so I move up to the top room. Yay, look at me go. I'm moving up in the world. And either way you do it, when you divide, where you do the powers. On like bases, you subtract them. What is 3 minus -1? It'd be 3 plus 1 is 4. But if I were you, negatives screw us up. That's why I always recommend flip it. So then there are no negatives. You're not going to make that negative mistake. This is just 3 plus 1. Same freaking answer, right? So what about this? Here's the last problem we'll do, kids. I don't know why I just said kids. Just leave me alone. So what I would do with this is a mamma jamma problem. What are the only things in that problem that want to move? Anything that's to a negative power, right? So you don't have to do what I'm saying. You could just apply the rule and subtract the powers and go from there. But it'd be so easy to make a negative mistake as you do that. So what I recommend, that's going to move. What else is going to move? These B's are going to switch places, right? They want to go down, they want to go up. And these three C's want to go up, right? So these guys want to go up, these guys want to change places. Let me stop for a second. Negative power means flip. So if it's on the top, it wants to go down. If it's on the bottom, it wants to go up. That's all a negative power means is flip. So how do I rewrite that? The a squared is sitting there, the other 7a's come up with it. The b's switch places, those 5 come up. B's. And those 4 go down. Those c squareds stay, they like it up there. And then these 3 c's come up here. And now look, how many total a's do I have on the top? 9. How many b's do I have? Where? On top. And how many c's do I have? Kabam. So again, you don't have to move the negatives. The rules stay the same as always. It's just if you do move them, you're going to make less negative mistakes. Okay. I think that's a part of section, I don't care, it's coming up pretty soon. 6-4 is where we start dividing stuff, so I think that's where the negative stuff comes into play. 6-4? No, 6-1. Yeah.
Would the answer still be correct if I wrote B5 and then C5? Like, do you have to combine them now?
I'm sorry, what?
Would the answer still be correct if I wrote B5 and then C5? Like, do you have to combine the B and the C?
No, careful.
Okay.
I don't have 5 B's, so that would be wrong.
Isn't it?
I have 5 B's, and didn't I just divide 4 of them away?
Oh, okay.
So your answer has to have 1 B.
Okay.
I like it. If I had 5 B's and 5 C's, I could write it like this, but see how I need the parentheses to tell me they got 5 of each? So this means 1 B and 5 C's because I lost 4 B's.
Because that line means division.
Yes, we know this means division. And what do? Like basis, subtract the powers. Subtract the powers that be, kids. All right.
So what the exponents,
Okay.
so what the exponents would be, division is multiplication, I mean subtraction, and then.
Yeah, it's kind of nice, the analogy there. When you multiply like bases, you add. So when you divide like bases, you subtract. That's a beautiful analogy, right? If you let it be. Let it be, let it be. All right, I think it's enough. I'm going to go even goofier. Like try to keep going. So next week, huh?
The face of the hand up.
Don't worry about it.
No?